and do our test review. We're going to take the Chapter 1 Test B. This is our practice test. The first thing they ask you to do is write interval notation. So on the interval notation, you just want to remember to match up your symbols and to write down your numbers. So your low number on number 1 was -8, and your high number was -4. On the symbol side, I've got a less than symbol, so I need to use a parenthesis, and I have a less than or equal to. This little line down here means that you're going to use a bracket for that. Number 2 says that you've got 1, and x is all the way up here. You see this little arrow marking means that you're going to go all the way out to infinity. So the lowest number you have is 1. The biggest number that you're going to have is infinity. I cannot trap infinity because it's an idea. And I have an open dot here, so it means I do not include 1. I need to use a parenthesis. If you need to go to set builder notation next, that's just this backwards. So number 3, in set builder, you're going to go from -infinity to +3. So you're going to go, here's your brace, x such that from -infinity all the way to +3 is going to be x is less than or equal to +3. I'm going to use less than because we go from -infinity on the low side. The highest number it could possibly be is 3. I use a bracket here, so I have to use less than or equal to, this little bar down here. Then we're going to say or, and then from 6 to infinity is the next interval. So x has to be bigger than or equal to 6. Again, the same rules apply here. I'm using a bracket, and that means I have to use or equal to down here. Number 4. They're asking for the set of all rational numbers greater than 5. So set up your brace and x such that you're going to say that x has to be greater than 5 and x is all rational numbers. Like that. Okay. So let's go on then. This was basically most of 1.1, the first section that we learned. On number 5, they're going to ask you to write the equation of the line, interpret the slope, and then look at the y-intercept. All right, so number 5 is asking you to write the equation of that line. So what we're going to need first is the slope. That's why they gave you these 2 coordinate points, so you could find the slope. So the difference in y is 1,300 and 800. 1,300 and 800. The difference in x is 10 and 20. I can already tell I'm going to have a negative slope because this line is sloping down. So when I take out my calculator, I'm going to see 1,300 minus 800 is 500, and 10 minus 20 is just -10. That means your slope, when you reduce the fraction, is -50. Since we know y equals mx plus b, we already know m is -50. We just need to look on our graph to find b, the intercept. That's going to happen right here. It's exactly halfway between 1,500 and 2,000. The halfway point between 1,500 and 2,000 is 1,750. So that's your B, 1,750. Now that you've got all of the pieces of the equation, it's time to substitute in, and you're going to have y equals -50x plus 1,750. That's us writing the equation in slope with a y-intercept. Number 6. I can already tell I'm going to have a positive slope. The slope is going to be 45 minus 30. 45 minus 30 is 15. And on the x side, I have 5 minus 2. 5 minus 2 is 3. This means my slope is 15 divided by 3. In other words, my slope is 5. Let's look at the intercept here. Where the line crosses the y-axis is at 20. So I know that my b has to be 20, my intercept. So y equals 5x plus 20. Number 7 is a little bit different because I can tell that this line has a slope of 0. In other words, it's flat ground. So if I were to say m equals 0 for number 7, if m equals 0, y equals mx plus b, 0 times x will go away completely. So all I'm going to be left with is my intercept. My intercept happens at 6. I can tell that I'm going up by 2's here. 2, 4, 6, 8. So when y is 6. So when you simplify this, y equals 6 is going to be the equation of the line because the slope is 0. All right, guys. Next one up is going to be transformations. So this is now getting into section 1.3 in the textbook. So let's look at number 8. They want us to match the transformation with the graph. So number 8. Let's look at number 8. I can tell that it has been reflected, all of the y values are now negative. And it's also been shifted up 3 units. Just looking at this lets me know that if it's been shifted up 3 units, that means this is the only graph that has a b value, a y-intercept of plus 3. So 8 has to be C. 8 matches C. 9 says 3 times the function, so it's going to be 3 times steeper, and it has to go through, on the y-axis, it's going to go through -1. The only graph that goes down here through -1 is B. So 9 has to be B. And we can also check that slope again. So you go up 1, 2, 3, and then over 1. All right, and number 10. It kind of means that it has to be A, but here's it going through, here's your graph going through +1. So that's going to be A. All right, that takes care of some of 1.3. Now we need to look at our absolute value functions, and this was starting to get into 1.4. Remember, your absolute value is just 2 straight lines that have different slope. So, like that. You're going to have one side that has a negative slope and one side that has a positive slope. To be able to solve it, we just need to separate this into 2 different lines and solve those lines. Number 9, 10, 11, number 11 says the absolute value of m plus 8 equals 12. So from this, what we just learned here, what we're talking about on number 11 is you're going to have one that's going to have a positive 12, and you'll have one that has a negative 12. When you go to solve this absolute value, you're going to break it into 2 different lines, and that's why we're not going to use absolute value signs right here, because we're not talking about that. We're talking about 2 different lines right now. Subtract 8 from both sides. So m has to equal 4. M has to equal -20. All right, and we can box those in. Just real quick, you can look up here and you can see that this is not an extraneous answers. None of these are, because it's going to equal a positive 12 no matter what. So no matter what you're going to put in here, it will come out positive and should be equaling this 12. All right, number 12. On number 12, they ask us for 5y plus 2 in an absolute value equal to 7y. Notice, when we start getting the, there we go. When we start getting the variables on both sides, that means that we're going to have to check for extra answers, extraneous answers. You're going to have, just like up here, you'll have one that's going to equal positive 7y and one that equals negative 7y. All right, so let's solve this out. I'm going to subtract 5y over here. I'm going to add 7y over here. I'm going to subtract my 2. And let's figure out where we end up. 5y minus 5y cancels. Bring your 2 down. 7y minus 5y is going to be 2y. 5 plus 7 is 12y. Minus 2 and plus 2 cancel to 0. Negative 7 and positive 7 go to 0. And you're left with negative 2. So we'll divide out. And you're going to get one where it says y equals 1. You're going to get another where it says y equals negative 2 over 12 is negative 1 over 6 when you simplify. And let's just look really quick up here. If I put a negative number, and if y is negative 1 over 6, and I put it in here, this will be a negative times a positive, which means this is negative. I cannot have some absolute value solution that would equal negative. So this is the extra answer that needs to go away, and this is the only true answer. Later, we'll get into a special case where there's going to be no solution, where we, for whatever reason, have to cross out both of them. And that's when you write no solution. All right, let's look at number 13. Number 13 says the absolute value of 4k plus 5 equals the absolute value of 3k minus 2. So we're going to do 4k plus 5 equals the positive 3k minus 2. Then we're going to have 4k plus 5 equals the negative 3k minus 2. This one's going to create an extra step for us because we're going to have to distribute the negative. But for now, we're going to solve this out by subtracting 3k from both sides and 5 from both sides. So when we do that, 4 minus 3 is just 1k. 5 minus 5 goes to 0. 3 minus 3 goes to 0. And negative 2 minus 5 is negative 7. So k equals negative 7. On this other side, when we distribute the negative, it's going to come to be 4k plus 5 equals negative 3k plus 2. Negative times a negative is a positive 2. I'm going to add 3k and subtract 5. This gives me 7k, and then over here, that goes to 0, that goes to 0. 5 and 2 are going to combine for me to get negative 3. We'll divide by 7, and we get k is negative 3 over 7. In both of these cases, no matter what I'm putting in here, it will come out of the absolute value as a solution that is positive, and the same thing over here. So both of these will work out for us, no problem. Let's go on now to 14, and we need to graph the inequality solution here. All right. So we're going to have 1 minus v in an absolute value, and it needs to be less than or equal to 9. Remember that your less than, or equal to's, this is when you're going to use and. In other words, you're going to shade inwards like this. X needs to be on the inside. And when you have these greater than, or equal to symbols, that's when you're going to shade opposite. In other words, your solution is going to be either here or here, but not in the middle. This one's going to be in the middle, not in the middle. And it all has to do with what kind of inequality symbol that you have here. So 1 minus v equals positive 9. And also 1 minus v equals negative 9. And I'm going to match up my symbols here where it says less than or equal to, just so we keep those right. I can add v and subtract 9. So I can get negative 9 plus 1 is negative 8. And then this will be v. So v is greater than or equal to negative 8. I'll go here. And then I can add v to both sides. Add 9 to both sides. And this will say 1 plus 9 is 10. Great. So let's go ahead and graph this out now. All right. So on this side, v greater than or equal to negative 8. We'll go over here to negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10. V has to be bigger than negative 8. So we come here. V has to be smaller than 10. So we come here. And then we shade in the middle. That's where your answer is. All right. Let's go on to number 15. It says 3x plus 15 is less than 6. So we've got 3x plus 15 less than 6. And then on the other side of that, we'll have 3x plus 15 greater than negative 6. Solve it out. Minus 15, minus 15. You're going to get 3x less than, and then this negative 15 and a positive 6. Remember, you can always use your calculator to help you out on your unit test here. So negative 15 and a positive 6 will get you that negative 9. And then over here, we're going to have 3x. That'll cancel. Greater than. Negative 6 and negative 15 is negative 21. Divide through by 3. You're going to have that x has to be less than negative 3, and then you also want to have x is greater than negative 7. So we'll come over here, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. And we know that our x has to be between negative 3 and negative 7. I'm going to use an open dot here, again, because it's not equal to. It's just greater than. So we don't include those points. Let's do some greater than work. Remember, your greater than is going to be the one where you split apart into different directions. So we're going to have 3 minus the absolute value of x plus 8 greater than or equal to 5. So on this one, I'm going to go ahead and subtract 3 from both sides. That's going to get me negative absolute value x plus 8 greater than or equal to 2. I need to go one step further because I need this side to be positive. So I'm going to go ahead, divide by negative 1, and I'm going to get x plus 8 in an absolute value symbol is less than or equal to negative 2. Now, no matter what the inequality says, there's nothing that can come out of here that won't be positive. So even if x is negative 1 million, it will come out as a positive 1 million, and 1 million is not smaller than negative 2. So on number 16, this is one of the special cases that you can write no solution, because your absolute value will not be negative. Let's look at the other one. We're going to divide both sides by -3. And when we do that, what's going to happen once this goes to 0, or 1, excuse me, 2a minus 4 in an absolute value, you need to flip your inequality, because what just happened is you divided by a negative. So this greater than is actually going to become a less than. 12 divided by 3 is 4. Now you can split your absolute value into two different ones. You're going to have 2a minus 4 less than 4, and 2a minus 4 greater than -4. Solving it out, you get 2a less than, this is 4 plus 4 is 8, and this is 2a greater than 0. Now we can solve this out. A is less than 4. A is greater than 0. So let's go to -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. So we got to be between 0 and 4. Just like that. All right, that takes care of our graphing inequalities. After we solve them, let's go on to the backside. Number 18, a can of soda must have 35 milligrams of sodium and the absolute deviation of 2.5 milligrams. Write and solve an absolute value that represents the acceptable amounts of sodium. All right. So usually absolute deviation is fairly straightforward. On this one, you just basically want to say however much sodium is actually in there minus the 35 that is required to be in there. That has to be less than or equal to 2.5. So if you think about it, 35 milligrams with an absolute deviation of 2.5 milligrams, that means that on the high side, you could have 37.5 milligrams of sodium, and on the low side, you could have 32.5. So if I put 32.5 minus 35 is -2.5. When you solve the absolute value, this is going to be a positive 2.5, and positive 2.5 is less than or equal to 2.5. So that works. On the high side, 35 milligrams plus 2.5 is 37.5. So if I took 37.5 in here and I subtracted 35 from it, I would still get 2.5. And that's why this works. This is your final answer here. That's the absolute deviation. If you want to graph parent functions, this is x squared. So remember, that's from 1.1, all of your parent functions. And the x squared is your quadratic. So you're going to go 1, 1, and then, there we go, 1, 1, and then 2, 4. There it is. And over here, same thing, 1, 1, and then 2, 4. And that is. So this is my parent function, and I can see that this 2 is outside of the x grouping. This means that it is a vertical stretch by a factor of 2. Let's take a look at the next one. I know that this is my linear parent function, 1, 1, 2, 2, 3, 3, 4, 4. That's my parent function, straight line. And two things are going on here. This plus 6 is outside of the grouping, so that is up 6 units. It's another vertical movement. This x is outside of the grouping, and so that's the one that's opposite. Remember, this is reflection in the x-axis. Very last one over here. Two things going on here, same thing. My number 3, the coefficient, is being multiplied against and it's outside the grouping. So that means this is a vertical stretch by a factor of 3. And there's a negative sign and it's outside. So that means reflection in the x-axis. All right. So we know that the table below shows the height of a football kicked over time, we know that a football, when you kick it, is going to go up in the air and it's going to go down. This parent function is the quadratic parent function. We know that if the parent function is right side up and this is upside down, that there has to be some sort of reflection in here, and it's also been moved up and over. So we're gonna use this to kind of predict out what the height of the football will be after 8 seconds, and this is going to be through the calculator regression. When you use the Inspire and you go to the regression, remember what type of regression you're running. It was linear, but this is not a linear function, so you'll want to run a quadratic regression. Let's talk a little bit about these transformations here. If you want to reflect something in the y-axis, this means that you need to tuck a negative sign in front of x inside the grouping. So -2, absolute value, negative x minus 1 is what that looks like. The next one up says 2 units up. So to go 2 units up, you need to be outside of the grouping. This is, oh, you know what? It says write a function g, and I accidentally named my function f. So I'm going to stop right now. I'm going to go back, and I'm going to name my function g, so I make sure I get full credit. So now let's continue. 2x, and then 5 plus 2 is 7. We're going to do a graph. It's a vertical stretch by a factor of 3, translation 2 unit up of x squared. So we're going to start with y equals x squared. We're going to do a vertical stretch by a factor of 3, so that means 3 has to be outside of the grouping. And then we also need to move it 2 units up. So again, we're going to put a plus 2 out here that's 2 units up. The very last one, they give us this equation. And the ball, it's a golf ball problem. So the golf ball gets hit, it goes up in the air, and it comes down, just very similar to number 22. After you're hitting the shot, though, your friend claims that if you strike the ball half as hard, your shot will be more precise. So find your new shot equation and describe how this transforms the graph. Essentially, you want the entire flight of the ball to be half, right? You don't want just one thing to be half, or one element, or one term in the equation. You want the whole thing to be half as hard. So remember, when you are multiplying the entire equation, you're talking about a vertical shrink by 1/2. So you're going to distribute this 1/2 through multiplication to all of the terms here. So -7/2 x squared plus t squared plus 35t, and then plus 3/2. This will be your new equation. -7/2 x squared, or t squared, plus 35t plus 3/2. All right, find your new shot equation, and then they want to know how high the ball will be after 6 seconds. So we're going to substitute 6 into this equation, and that will bring us to our final answer. I'll catch you guys on Monday and Tuesday. Have a great weekend.